Hey everyone, welcome back to the College Algebra playlist. In this video, I'd like to take a look at the x and y intercepts of linear and quadratic functions. Alright, so let's dive into it. Okay, here we go. Intercepts of linear functions. Given a linear function f of x equals mx plus b, the y-intercept of the function is the value of f of x when x equals 0. Okay, it's the value of y when we're at a horizontal position of 0. We're somewhere on the y-axis. If the equation is in slope-intercept form, like it is here, then the y-intercept is given as 0, comma b. Okay, let's see an example. Here we have the function f of x equals 1/2 x plus 3, and we want to find the y-intercept, right? We want to find the y value of this red point here. So to do this, we need to plug x equals 0 into the function to find the y-intercept, okay? So we're going to evaluate f of 0. All right, let's plug a 0 here in red in for x. That gives us 1/2 times 0 plus 3. 1/2 times 0 is equal to 0, and 0 plus 3 is equal to 3. So we have f of 0 equals 3. Which means that the y-intercept is given as 0, comma 3. Here it is. You say, Luke, why did you go through this work to find the y-intercept? You could have just looked at the equation and written down the y-intercept immediately, right? It's 0, comma b. This is the value of b in this case. I'm showing you this process because it's not always going to be this easy, all right? When we're dealing with more complicated functions like rational and radical functions, we need to plug x equals 0 into the function to find the y-intercept. Okay, this is the process that we go through. So in this case, we can go through that process, and we can also just look at this number here to verify that our answer is correct. It's 0, comma b. Given a linear function f of x equals mx plus b, the x-intercept of the function is the value of x when f of x equals 0. Okay, it's the value of x when y equals 0, right? You're at a height of 0. You're somewhere on the x-axis. All right? Let's try it out. Here we have the function f of x equals 1/2 x minus 3. And we're trying to find the x value of this blue point here. Okay? So we set f of x equal to 0 to find that x-intercept. And that gives us the equation 0 equals 1/2 x minus 3. So we need to solve this equation by isolating x on the right-hand side. Okay, let's add 3 to both sides, and we'll get 3 equals 1/2 x. Okay, and then we'll multiply both sides by 2 to isolate x on the right-hand side, and we get this. And we can see that the 2's cancel on the right-hand side, and that gives us 6 equals x. Okay? So the x-intercept is given as 6, comma 0. All right? Let's move on to quadratic functions next. Given a quadratic function f of x equals ax squared plus bx plus c, the y-intercept of the function is the value of f of x when x equals 0. All right? And if the equation is in standard form, like it is here, then the y-intercept is simply given as 0, comma c. Okay? So let's try this out. Here we have the function f of x equals 2x squared minus 6x plus 2. And we're looking for the y value of the red point. Okay? So we plug x equals 0 into the function to find the y-intercept. Let's evaluate f of 0. All right? When we plug 0 into the function, we get 2 times 0 squared minus 6 times 0 plus 2. Right? We're plugging 0 in for x here in red. All right? This product here, 2 times 0 squared, is equal to 0. Okay? And negative 6 times 0 is equal to 0. So that just leaves us with plus 2, which means that f of 0 is equal to 2. So the y-intercept is given as 0, comma 2. Okay? Once again, we could have just looked at this equation and written down the y-intercept right away, right? We know that it's 0, comma c if it's in standard form, so it's 0, comma 2 in this case. Okay? So notice the theme here. It's pretty straightforward to find the y-intercepts of linear and quadratic functions, but it's harder to find the x-intercepts. Okay, that takes more work. It takes more work, all right? Given a quadratic function, f of x equals ax squared plus bx plus c, the x-intercepts are the values of x when f of x equals 0, okay? The x-intercepts are also called the zeros, or the roots of the function, okay? We need to talk about 3 cases that arise when we look at quadratic functions, all right? If b squared minus 4ac is negative, remember this is the value of the discriminant. That's what it's called. If the discriminant is negative, that means we have a negative number under the square root in the quadratic formula, which means that the x-intercepts are complex, right? They involve imaginary numbers. So this curve crosses the x-axis in imaginary places, right? So that's what's happening there. And with case 2, if the discriminant is 0, then the curve just comes down here and kisses the x-axis somewhere, right? It just touches it in one place, all right? So that's what that looks like. And if the discriminant is positive, that means that the curve crosses the x-axis in 2 distinct locations, okay? Case 3 is probably the case you're going to see most often, all right? Here we're asked to find the x-intercepts of the quadratic function f of x equals x squared minus 2x minus 3. Okay? So what we need to do is set f of x equal to 0 in blue here to find the x-intercepts. All right? So what I'm going to do is take this f of x and set it equal to 0, and then swap the left and right hand sides. Okay, this is how we're used to reading it. We have x squared minus 2x minus 3 equals 0. All right? And remember my advice for solving quadratic equations. If the lead coefficient a is equal to 1, then we need to try factoring. Okay, this trinomial is actually factorable. It's x plus 1 times x minus 3. Okay? And then we can use the zero product property to write down these 2 equations here. And we solve for x to get our 2 solutions. All right? Let's start here on the left. Okay? We're going to subtract 1 from both sides. And that gives us x equals negative 1. And then over here, we add 3 to both sides. And that gives us x equals 3. Okay? So the x-intercepts are given as negative 1, comma 0 and 3, comma 0. All right? These are my 2 solutions. And we can visualize these here like this, right? Here's the curve f of x equals x squared minus 2x minus 3, and we can see that it crosses the x-axis in 2 distinct locations. Okay, so this is a case 3. Let's look at one more problem. Here we're asked to find the roots of the quadratic function f of x equals 2x squared plus 4x minus 4. Okay, remember the roots are the x-intercepts, right? They're also called the zeros of the function. So what we can do is we can set f of x equal to 0 and then use the quadratic formula, right? That's my recommendation when a is not equal to 1, right? Here it's some number other than 1. So the quadratic formula is a good choice. It's super straightforward and it always works. But here I'd actually like to show you a new method for solving quadratic equations, okay? What we want to do is convert the equation to vertex form. Now, why would we do that? It's because it becomes straightforward to isolate x. When we set f of x equal to 0, we can just subtract k from both sides and then divide both sides by a, and then take the square root of both sides to isolate x, right? This is one of the methods we've seen before, right? We called it the square root property. When the equation looks a certain way, you can just take the square root of both sides and then isolate x in a relatively straightforward manner, all right? So to convert to vertex form, what we need to do is find values for h and k. Okay, these are the coordinates of the vertex. And to do that, we can use the vertex formula, right? We talked about this in the previous video. the x-coordinate of the vertex is h equals this, right? It's negative b over 2a. Okay, so let's plug in the values for b and a to see what we get. All right, we have b in red is 4, so we'll put that up here. And a in blue is 2, so we'll put that down here. And that gives us minus 4 over 2 times 2, which is equal to minus 4 over 4, which is equal to negative 1. Okay? So the x value of the vertex is equal to negative 1. We don't know what the y value is yet. Okay? So let's find that next. To find this y value, right, to find the value of k, all we do is we plug minus b over 2a into the function. Okay? And we already found that minus b over 2a is equal to negative 1. All right? So we're plugging negative 1 into the function. And that gives us 2 times negative 1 squared plus 4 times negative 1 minus 4. Okay, that's what the function says to do. So we evaluate like this, and we get 2 times negative 1 times negative 1, which is 2 times 1, which is 2. 2 minus 4 is negative 2, and negative 2 minus 4 is negative 6. Okay? So the y value of the vertex is equal to negative 6. So we have all the pieces we need to write down this equation in vertex form, right? We know what a is in blue, right? It's 2. And we also know what h and k are as well. Okay? So let's plug negative 1 in for h, and we get x minus negative 1 in parentheses, so that turns into x plus 1. And then we plug a negative 6 in for k, that gives us minus 6. Okay? So we got the equation in the form that we wanted. And now, when we set f of x equal to 0 to find the roots, the equation is straightforward to solve. Okay? We have 0 equals 2 times x plus 1 squared minus 6. Okay? To isolate x on the right-hand side, we need to add 6 to both sides, and that gives us 6 equals 2 times x plus 1 squared, and then we divide both sides by 2, and the 2's cancel on the right-hand side, and that gives us 3 equals x plus 1 squared. Okay? What I want to do next is simply swap the left and right-hand sides. Okay? So that gives us x plus 1 squared equals 3. And now we're in a situation where we want to take the square root of both sides. Okay? If we take the square root of both sides, it gets rid of this exponent 2, and we can isolate x. Okay? So remember, when we take the square root of both sides and we're solving for an unknown variable, we need to include a plus or minus. Okay? The square root of x plus 1 squared, that just turns into x plus 1. And on the right-hand side, we have plus or minus root 3. Okay? One more step to isolate x. We just need to subtract 1 from both sides. And that gives us x equals negative 1 plus or minus the square root of 3. All right? Let's get rid of all of this work and take this to the left side of the screen. And let's also color code this, okay? F of x is equal to 0 in purple, right? That's the y value of the x-intercepts, okay? And then the x value is in purple as well. Here it's negative 1 plus or minus square root of 3. So the roots are given as negative 1 plus root 3 comma 0 and negative 1 minus root 3 comma 0. Okay? These are my solutions. And we can visualize this on the graph. Okay? Negative 1 plus square root of 3 is approximately equal to 0.7, and negative 1 minus root 3 is approximately equal to negative 2.7. So once again, this curve crosses the x-axis in 2 distinct places. And we could have used the quadratic formula to get these roots. Okay? I just wanted to show you this new cool way to find the roots. It's cool because it involves the vertex form, which we looked at in the previous video. All right? I really wanted to include some word problems in this video, but that would have made it too long. So we're going to save the word problems for the next video. All right, we'll see some interesting applications of this stuff. We'll look at a problem from ecology and a problem from physics. Okay? So that does it for this video. Thank you for watching, and like and subscribe.